fear the environment is better than America?
No. Actually, Virginia has to be why I don't think Texas. But no, that's where I did. My parents brought me there. I grew up there, went to school there. My wife. I mean, that's the thing. I would move to the Bahamas. But no, my wife works there, and she's a lawyer, and so she's the boss. Okay, other questions?
And what's the bounding force between all those nano powders?
In theory, we know it's mostly mechanical, but in the ceramics, it's mechanical strength. Now, as to why we're getting superior bond strength with nanoceramic coatings as opposed to conventional, I know the University of Connecticut has studied that, and it's not conclusive. I mean, we can't really figure out a clear reason for seeing that.
More material and smaller stuff.
It could be, the fact that you have these fine particles that readily deform, right? And so you may be able to do that, but we still haven't seen anyone do conclusive studies. And unfortunately, as much as I, having done the doctorate, I love to do a lot of peer research. I can't do it without money, right? And so I hope that academics can do these kind of things, but it's also tough. It's not easy when there's the funding is not.
Do you find that when you're applying coatings with HVOF, do you want to go any kind of phase changes?
For which type of metals?
For all valves, let's say.
Yeah. Phase changes from the original starting material?
Yeah.
You can depending on your parameters, you can change certain changes.
Because when they turn molten and then they're applied and they cool.
Right.
And over that course, of course, they get phase change. But once they're applied,
yes.
You see any more phase change?
Oh, in application, you mean?
Yeah.
I don't think we've seen that. Everything we've seen remains stable. In fact, I think that was the test that was carried out in British Columbia. Donald Lucas.
So if you're saying it remains stable over time, it changed, but it seems like those would be detonation energy to actually make that change in those conditions. Would that be high temperature conditions?
Well, yeah. What we did notice was, they were using chromium for a while, and this was presented several times in Alta, and I think some of the papers that published is chromium was the material they used to use before. And a lot of these oxides, when you spray it, depending on your spray environment conditions, you can change the stoichiometry. Like zirconia is off-white, you can spray it and it becomes gray. But in an oxidizing environment, typically they'll just go really quickly go back to revert to its stable phase. Zirconia is ZrO2. But however, this acid condition, we saw that chromium when you spray it, and if you don't get stoichiometry, it doesn't. It actually corrodes real fast before it can reach its stoichiometry condition. So the stoichiometry is very important. And, that's a lesson we learned. We have to keep an eye on that. Okay, let's think.
What about the mix of different types of powders, such as tungsten carbides, with this type of material?
Yes, the Navy actually invested quite a bit in tungsten carbide cobalt. It didn't, the results were not clear. And the main reason is, at the time, HVOF was the general way to go. And because your carbides are so fine, your nano scale, I mean, even at micron scale now, with conventional materials, we have degradation of the carbides. When they're that small, you completely decarbonize all the fine carbides. So at the end, you didn't have a coating of tungsten carbide cobalt. You had W2C, sometimes W, that react with the cobalt to form a HEDA phase. So you would sometimes get some improved hardness only because your matrix got harder, not necessarily because your carbides were weaker. With Gardner, we've been working on trying to apply it at lower temperatures. And we've been getting some really promising results. We've been working with Syncrude Canada, and some of the initial work we carried out shows that the wear resistance of the coatings we form are approaching those of plasma transfer arc, which is sort of like a micro welding technique. So that shows a lot of promise for us. However, we think that we can further reduce the decarbonization and hope that will even translate to greater toughness.
Is there any quality control process rather than visually see compared with 7 years later on nanostructure looks like, such as modeling simulation?
No, not there. We haven't done any modeling on these. What we did was those shafts that I mentioned, the 80 shafts. We were able to remove little sections of it, and then we carried out hardness tests. We carried out X-ray diffraction. We looked at the microstructure and SEM, and before service and after service, there was no real difference. So that's why we feel like it didn't really undergo any compositional degradation. As well as thickness, when we measured the thickness, for the most part, over 80%, it looked like the same thickness. So even the wear was very minimal.
Okay, so let's thank Dr. Pim, and if anybody else has questions, please see them individually. Thank you.